नमस्कार.
Hello,
हॅलो, नमस्कार.
Namaskar. We'll start in 1 minute. Yeah.
Yeah.
Hari Om, sir.
Hari Om. Yeah. Yeah. We'll start in 1 minute. We'll wait for 2 minutes if anyone else want to join. Okay. We'll start with a prayer. या कुंदेन्दु तुषार हार धवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिर्देवै सदा वन्दिता सा मा पातु सरस्वती भगवती निशेषजाड्यापहा. I will share my slides. Is it visible to all?
No, sir, not yet.
Not yet. Okay. Is it visible now?
Yes, yes.
Okay. So let's start with today's session. Last week, we have studied the combination of multiplication and addition technique. Here, we have learned that if we have to multiply two-digit numbers to each other, where the answer or the number of steps required are 2n minus 1, that is 3, and if we have to add three-digit numbers, then this technique is only applicable. If the number of digits needs to be added are not 3, then we can add a leading 0 to make the position adjustment. And it is a combination of vertically and crosswise, the urdhva tiryagam and the addition technique. So, let's see that we are multiplying 67 into 42. So we multiply 6 into 4 first, then we add 3 and 6 of the second digit. So then we get the answer 33. 33, we write it as 330. Then we do the crosswise multiplication. 6 into 2, 7 into 4, plus second digit, that is 4, and the second digit, that is 1. And we get the answer 375. 6 to the 12, 7 for the 28, plus 4 plus 1. Okay. So then we make that by adding a 0, make it 3750. Then we do the last digit multiplication, 7 into 2 plus 2 plus 2. So we come to the answer 3768. We have studied this last time. Also, one more example we studied. If there are more than two numbers, how to do it? Again, 4 into 9 plus 5 plus 6 plus 3. We get 50. We just make it to 500 by multiplying by 10. Then we multiply crosswise, 4 into 1, 9 into 3, okay, plus 4 plus 4 plus 2. We get 541. We make the 541 as 5410. Then we do the last digit, 3 into 1 plus 3, that is last digit, plus 2 plus 1. And then we get the answer 5419. We studied this technique last week and we have done the practice examples as well. So We also studied the algebraic multiplication that time based on x plus 3y, x plus 7y. The base is x times the base, whatever it may be the value, because x could be 10, x could be 100, x could be anything. So we just did that x plus 3y, x plus 7y plus 3y plus 7y. We multiply 7 into 3, 21y square. Then cross addition 3y plus 7y or 7y plus 3y. So it becomes x plus 10y. Into the left portion only multiply by the proportion, that is x. So x into x is x square plus 10xy plus 21y square. That is the method using the Vichalana, is a Sanskrit word. We can use that, which we learned in the base multiplication in the previous lectures. That is 104 into 105. That is plus 4 plus 5. 5 4 is 20. 104 plus 5 is 109. So answer is 109 and 20. It is the same method, only in the terms of algebraic way or in the combination of variables. We learned this last time. Now, today we are going to start with a special method, that is for the division. Okay. So, the problem is 612 divided by 6. Sorry, the symbol I am using is like that because of maybe presentation slides. I have to draw the lines every time. So, I took a shortcut. That 612 divided by 6. I hope it is clear to you the problem. So what we do, we just split the number in such a way so that it will be easy to divide. So I split the number 6 and I split the number 12. Then I just divide 6 ones are 6, 6 twos are 12. Only because there are two digits, so I simply write 02. One need to remember to write a 02. See, sometimes numbers are easy, so it makes sense to observe the number before do the mathematical operation. If we can use a simple technique, always we should choose the simpler path. No need to complicate the science for complicating itself. Okay. Suppose another example, 24, 45, 3 divided by 3. So we know exactly we can divide 24 is divisible, 50, 40, 50, 45 is divisible, 3 is divisible. So split it. Then divide by 3. 3 8s are 24. So we write 8. We can write 08. Okay, because it is 2 digit. But 0 has this no meaning because it's a leading and top 0. 45 divided by 3. So answer is 15. 3 ones are 3. So final answer is 8151. So by mere observation only, we can do the division faster. That is what the method, or that is what the thing I wanted to suggest here. Now, another technique of division, which is near to the base. Okay. So division by 9, suppose. How to do it? 9, 23 divided by 9. So we simply pull the 2 as it is. Pull down 2 as it is, write 2 as it is. Okay. Then 2, add it to the next digit. Okay. But reality, it should be the difference between the base is 1. Base is 10. So it is written as 10 minus 1. So you pull the 2 down and then 2 you multiply with a difference, that is 1. So 2 1 are 2 plus 3, that is 5. Okay. So this is the real way, but I will explain in the next sum how, or the next lecture, how to use this Vichalan from the base. But for now, just remember, if we have to divide by 9, just pull the number as it is, then add it to the next number, write it down. That is the method. Yeah. Suppose next problem is 66 divided by 9. So I simply pull 6 as it is. 6 plus 6, 12. My first iteration answer is 6 and remainder is 12. But 12 is greater than 9. So again I have to repeat the procedure. So 12 divided by 9. So I write 1 as it is, pull down 1 as it is. 1 plus 2 is 3. Now 3 remainder is less than 9. So I got the answer in the second iteration 1 and remainder 3. In first iteration I got 6 answer, 12 remainder. So I simply add all the device answers. 6 plus 1 is 7 and remainder is 3. So this way, by iterative method, you can do the division for a number which is near to the base or divided by 9. I hope is it clear how to divide by 9 to any number?
Yes, sir. It's clear.
Yeah, it's very simple technique. Divide by 9. Okay, now let's focus on to the more detailed method for any number. Okay. Called the crown jewel of the Indian mathematics, or the Vedic mathematics. This method is called a flag technique or Dwajank technique. Suppose I have to divide 209 divided by 52. So I write 5 below, make 2 as a flag. As the flag go up on the mast, so I write 2 on the top. Then, depending on the number of digits in a flag, I just take the left 1 digit, make a vertical line. The vertical line, this denotes a remainder line. Okay. Then I write one horizontal line for answer. Then we try to divide 5 by 2. We cannot divide 2 by 5. So I take a next digit 20. Okay. So 20 by 5. Answer is 4. Remainder is 0. So I write answer 4 here. Remainder on above the line. Then next step, I take 0, 9. Then multiply answer 4 with a flag. 4 into 2. 4 into 2. And subtract that from 9. 9 minus 4 into 2, that is 1. So that is 1. 1 we write 4 into 2, 8. 9 minus 8 is 1. Okay. So answer number 4 multiply by the flag 2 gives the 8. And this is subtracted from the 9. So I got the answer 4. And the number which appears on the right side of this vertical line is a remainder. So remainder is 1. So answer is 4. Remainder is 1. Is this technique clear? How to do it? See, original problem is 209 divided by 52. Yeah. But by using a flag method, we can do it very easily. Even complex division is possible with this technique. I will teach you all that as well. Yeah. Even decimal point division is possible. We don't need to use the calculator to do that. Okay, I will teach and I will cover in a subsequent classes this method. But first of all, ensure that you understand the basic method first and you master this flag technique. Is this technique clear or do I need to explain it again?
To take one more example, sir.
Yeah, I will take one more example and we will practice it. Yeah.
Yeah, thank you.
Let's go to the next example. So, little complex scenario. Okay, but before I go to complex scenario, I just wanted to ask, is this particular simple sum clear?
Yes, okay.
Yeah, to everyone, if it is clear, then I will move to the more complex scenario. Sorry. Okay, now little complex scenario. Okay, so 503 divided by 72. Okay, so I write similarly 7 down to make 2 as a flag. There is 1 digit in a flag, so I just take a vertical line before 3. Okay, then I take 5. I cannot divide 7 by 5, so I take a next digit 50. 50 divided by 7. 50 divided by 7, answer is 7, remainder is 1. 7 7 is 49. Okay, so answer is 7, remainder is 1. I write remainder on the top. Now, next digit is 13. Yeah. And we need to reduce that 13 by 7 into 2. So, but 7 to the is 14. Okay. I cannot subtract 14 from 13. It's not possible. Okay. I cannot subtract 14 from 13. Okay. So, what I need to do, I reduce the 7. I reduce the answer 7 by 1. So, make it 6. Okay. So, when I make it 6, that 1 remaining is nothing but a 7. Yeah. So, or something like that, 50 divided by 7, to get the answer 6, we get the remainder 8. Or we add that 7 into 1, that makes 8. So, number becomes 83 now. Yeah. 83 minus 6 to the 12. Okay, 6 to the 12. So, 83 minus 12 is 71. Hence, the answer is 6, remainder is 71, because 71 is less than 72. Okay, so my answer is correct now. Is this clear? How I did the adjustment? Why I made 6 from 7? Why I reduced by 1?
Yes. Yes.
Yeah. I will explain again. See, original sum is 503 divided by 72. Sorry. Yeah. So I write 2 as a flag, make 2 on the top, make a vertical line before 3. Then I divide 50 divided by 7. 7 sevens are 49. Remainder is 1. I write it here. So out of that 13, I need to subtract 7 minus 2. 7 into 2, 14. I cannot subtract 13 minus 14. Okay, that is not possible to get the correct remainder. So what I need to do, I reduce my division by 1. So I make 7, I make reduce 7 by 1, make it 6. Then if I make it 6, the value of that 1 is nothing but a 7. So I add that 7 into this one. So 7 plus 1 is 8. Or suppose if I write 50 divided by 6, to get the answer 6, obviously I get a remainder 8. Yeah. So similar way. So 50 divided by 7. Yeah. So remainder is 8. So I write the 8 here. Yeah. Now the next number is 83. Yeah. 83 minus 6 to the answer into the flag. So answer into flag is 12. So 83 minus 12 is 71. So finally I got the answer 6. Remainder is 71. Clear?
Yes.
Is this clear or not clear? Or you find it complicated?
Little more practice, sir, I think.
Yeah, okay. Take a pen and pencil. Okay. And let's practice it. Okay. Take any example. 103 divided by 43. 103 divided by 43. How you will do it? Four down here, 3 here as a flag. So 10 divided by 4. Answer is 2. 4 to the 8. Remainder is 2. So next number is 23. But we already crossed the remainder line. So we don't need to continue on the division process. We just need to find the correct remainder. So 3 to the 6. So 23 minus 6. So answer is 17.
17.
Okay, and 17 is less than 43. So this sounds to be correct answer. So answer is 2 and remainder is 17.
7.
Clear?
Yeah. Yeah.
Right? This is the beauty of Vedic mathematics. You don't need to remember the table of 43. No need to make it complicated science, okay, or multiply nearest number. It is very easy to do, taking single digit at a time. Clear? Is this method clear?
Yes.
Yeah. If anyone has any question or not clear, please ask now.
Can we do one more complex sums?
Yeah, we will see. Today, I'm going to cover only simple sums. Once you are familiar with the technique, I will go for the next class. For next 2 or 3 classes, I'm going to teach this method only with more and more complex sums. Means even 5-digit number divided by 4-digit number, something like that. So we will learn that. But first of all,
Something like the previous slide. Something like the previous slide.
yeah, something like a previous slide. Okay, just 1 minute. This one you mean here, T503 divided by 72. Yeah?
Yes, yes.
Okay, let's pick any example from homework. Okay, say 543 divided by 82. Yeah, let's try. Like, okay, so 54 divided by 8. How much it is? 8 6 are
48.
48. What is the remainder?
6.
6. Okay,
Six.
sorry.
6.
Again, it is easier. Okay, so maybe that doesn't address the scenario. Maybe 234 divided by 54, because see, intention was to do the simple sum initially to get the practice. Okay. Yeah. Okay. Suppose now it is 5 4 the 20, 34. Then again 4 4 the. Then again it is same way. Again it is a simple problem. It's not complicated.
Simple.
Yeah. Maybe make some complex problem. No, again it is a simple. Okay. I will find maybe some complex scenarios. In the next class, I'm going to cover more and more complex scenarios.
Okay, sir.
Yeah.
Okay, sir.
Yeah. First, mainly what I wanted to suggest is that go for the technique first. Means understand the technique first. Once you are familiar with the technique with a simple problem, then in the next classes we will cover more and more complex scenarios. Yeah. Or even we can change this similar problem.
Sir, please can you repeat this again?
This
Steps.
sum again.
Steps.
Yeah.
All steps again you
Steps.
have to repeat.
Okay. Yeah. Suppose the sum is 209 divided by 52. Yeah. So I write 52 in such a way, I write 5 down, make the 2 as flag. Okay, flag means move it up. Then in the flag, there are only single digits. So I put a single, leave the single digit from the right, make a vertical line. This line is called remainder line. Then I put a one horizontal line. Yeah. Then I divide the 20 by 5, only 5. So 20 divided by 5, answer is 4, remainder is 0. So I write remainder on the top here. Yeah. So answer 4 here, remainder 0. Next number is 09. Yeah. Then from 09, we subtract the answer into flag. Answer into flag. Answer is 4, flag is 2. So I subtract 9 minus 8. 4 to the 8. So answer is 1. I write it, the answer that 1 here. So my final answer is, answer of the division is 4 and remainder is 1. Clear?
Okay.
Okay. In the complex problem like this, suppose problem is 503 divided by 72. Okay. So if I take this as an example, okay, so I put 2 as a flag, make 3 as a remainder section, put a vertical line, put a horizontal line. Then I divide 50 by 7. Okay, so 50 divided by 7 is 7 sevens are 49. So I write 7 here, remainder 1 on the top. Clear? Now, as I cross the remainder line, now I need to only calculate the remainder. But so 13 is the number minus answer into flag. 7 to the 14. Can I?
14.
Yeah. Can I subtract 13 minus 14? No. Yeah.
No.
So 13 minus 14, I cannot subtract. So what I did, I reduced the answer by 1. Make it 6. Reduce the 7 by 1, 6. When I reduce the 1, what is the value of that 1? Obviously 7, because I am dividing by 7. Clear? So 7 plus 1. So I write 8 here. Or another way of thinking is that 50 divided by 7 to get the answer 6. If I get the answer 6, what is the remainder? 8. So I write 8 here. Okay. Then from 8, 83, I subtract answer into flag. 6 into 2, 12.
62.
Yeah, no, 6 into 2,
12.
12. So
12.
83 minus 12. 83 minus 12 is 71.
71.
Yeah, so I write 71. So my final answer is 6 and answer is 71. Clear?
Remainder is 7.
Yeah. Or maybe let's solve one more problem. I think it could be, suppose I take a number 513 divided by 82. Yeah. Is this visible to all of you?
Yes.
Yeah. So now 51 divided by 8, how much it is? 6. Clear?
6.
Yeah. What is the remainder?
3.
3. Okay.
3.
So next number becomes 33. 6 into 2, 12. Okay. So 12, 33 minus 12, how much it is? 33.
21.
21. So answer is 6, remainder is 21. Clear? Original problem was 513 divided by 82. Answer is 6, remainder is 21. Even we don't know the table of 82, it is fine. This method is very easy to do. Yeah? Clear?
Yes, sir.
Yeah, very simple technique. First, what I will suggest is to practice the simple technique first. The reason is that you need to understand. It's like a, do you know how the weavers weave the clothes on that wooden machine? Okay, they have one handle which they pull near to them, one handle on the top they pull. Okay, the flag technique is derived from hand weaving. Okay, or this division is exactly the simulation of a hand weaving. Okay, so what to master the hand weaving and the complex scenarios of hand weaving, one need to practice the basic technique first. Okay, that's why I didn't rush into the complex method. I wanted to teach it very slowly. Yeah.
Yes.
Yeah. So first master the basic fact first. Once you have become a master of the basic thing, complex thing, you won't make any mistakes. Yeah.
Yes.
Okay. I hope
Yes.
this flag technique is clear. Yeah.
Yes.
Now let us talk about today's Subhashit. Vidya Vidya Daya Dhanam Madaya Shakti Paresham Paripidanaaya खलस्य साधो विपरीत मतेत ज्ञानाय दानाय च रक्षणाय. Very interesting, Subhashit. A crooked man use his knowledge, okay, for only argument, okay, and he obviously he argue very cleverly, very smartly. He argue with very subtle points and all because he is using his knowledge for a wrong doing. The crooked man also use his wealth, okay, to become an arrogant person. Okay, if the crooked man gets dhana or wealth, he becomes a very arrogant person. He uses his power to harm others, or Shakti is used to harm others. But
Correct.
the true person or the good man or gentleman is the opposite is always true. He or she uses his knowledge for good purposes. His wealth is used to donate to others or to doing danam. Okay.
Yeah.
Or he uses his power or strength to always to protect the weak. Okay, very interesting, Subhashit. Yeah. So if somebody is very cleverly arguing, but in a bad nature, okay, he's using his vidya or he's using his knowledge for wrongdoing. Okay. So what this Subhashitkar wanted to tell us that we should be very careful where we should use or how we should use our vidya, how we should consume the dhana or wealth, or how we should donate or use it for donation, and we should use our power in hand very wisely, okay, to protect the weak in the society, okay, not to use that power to harm others. Okay, interesting, Subhashit. Yeah. So I hope today's lecture is clear to all of you. Do you have any questions from the last lectures or last techniques what we learned?
Yourself. So.
Hmm? If you have, please ask. Yeah. Okay, because it is very important that see next step we are going to into the more depth of the flag system or the flag technique for division. You will be able to make a very complex divisions of say 6-digit number by 3-digit number, 5-digit number by 4-digit number, or even 8-digit number by 4-digit number division is possible. Okay, so we are going to climb a steep curve. So that's why I want you to practice this Dvajanka technique very well. Yeah. And once you understand and practice this flag technique, you don't need to use the calculator anyway. Even you can find any division in a decimal point up to 5 decimals, 10 decimals orally. Okay, and it is technically possible. Yeah. And see, the way we learn the division in the school, Indian technique is much more easier because it only dealt with one digit at a time. Okay, it is not dealing with 82 or complex numbers at the same time. Okay, say 503 divided by 72 or 209 divided by 52. A student don't need to remember even the table of 52. Okay, to divide. And the beauty is that even if you take the number, no matter how big, the technique remains same. Yeah. So it is very useful technique. So I will suggest you to practice it, practice your homework thoroughly so that you understand the basic steps. Once you understand the basic steps, then it is very easy. Yeah. See, even this sum, say 9 divided by 20, 30, 10. Very simple. Pull the two down. 2 plus 0 is 2. 2 plus 3 is 5. So answer it method is very simple in Indian mathematics. 20, 30, 10 divided by 9. Yeah. Very simple technique. You just pull 2 down. 2 plus 0, 2. 2 plus 3, 5. 5 plus 0, 5. 5 plus 10, 15. Okay. Now answer is 2255 plus 15. But in 15 can be again divisible by 9. So we divided by 15 divided by 9. Okay. So 1 as it is. 1 plus 5 is 6. Okay. So answer is 2255 plus 1. So final answer is 2256. Remainder is 6. See, even this complex problem can be solved so easily. Yeah. I hope you understood the technique. 2 as it is, 2 plus 0 is 0, 2. 2 plus 3 is 5. 5 plus 0 is 5. 5 plus 10 is 15. Yeah. It's a hand waving. Yeah. Pull down, move next. Pull down, move next. Pull down, move next. Yeah. Yeah. Clear?
Yes.
Any doubt in those techniques? What we learned today? Yeah. If you have any questions, feel free to ask. We'll stop for today. I will send you the homework, I will send you the slides, and I will send you the video as well. Yeah. Okay, but
Thank you,
practice
sir.
this. Yeah, practice this flag technique very well, because without that you won't be able to understand the next few lectures. Yeah.
Yes.
Okay. Thank you. Have a nice day. Bye.
Thank you, sir.
Thank
you,
you, sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you.